In today's notes, we are going to learn how to factor quadratic functions when a does not equal 1. Remember, our formula for quadratic functions is ax squared plus bx plus c. At the top, you're going to notice that we already have an example done for us that runs through how to do exactly every step with the x and the box method. So we're going to jump straight down to example 1 and use the same techniques. In example 1, you'll notice that our a is no longer 1, we have a coefficient of 3. So when we are trying to figure out our multiples, it's going to change some things. Again, we multiply a times c to figure out what we're multiplying to. In this case, a is 3 and c is 7. So we're trying to figure out multiples of 21. I know that 1 and 21 and 3 and 7 are the only multiples of 21. In the bottom of our x, we are going to be putting our b term. In this case, that b term is 10. And we want to figure out, of these options, which of these will add or subtract to 10, as well as multiplying to 21. 3 and 7 are the obvious choices, as 1 and 21 would never add up or subtract to 10. So we've figured out our factors, but what does that look like over in the box and with our final answer? First, we put 3x squared, our first term, in the upper left, and 7, our last term, in the lower right. We already know that our terms are 3x and 7x. Our factors are 3 and 7. So I'm going to go ahead and put those in our box. But what does that mean our factors are to make this? Well, I need to start thinking about the greatest common factors that I can pull out of each of the columns and rows. So let's start with our columns. 3x and 3x squared. I know that I can pull a 3 out. And I also know that I can pull 1x out. This has 2 x's and this has 1. So at most, we can pull 1x out. This is our greatest common factor for this column. In the next column, we can pull out a 7. We can't pull out an x because this 7 doesn't have any x's to give. So 3x and 7 will be our final greatest common factors for these two columns. We now need to pull out the greatest common factor from each row. In the top row, 3 and 7 have no numbers in common, so we can't pull a number out. But x squared and x means we can pull 1x out. 3x and 7 have nothing in common, so there's nothing that we can pull out, but we do need to finish the factor, so we're going to actually just pull out a 1, because 1 will go into 3x or 7 always. This gives us a final answer of 3x plus 7 and x plus 1. Now, it's always good to double check our answers, and we can do that by multiplying this polynomial out. So 3x times x would give us 3x squared. 3x times 1 would give us 3x. 7 times x would give us 7x, and 7 times 1 would give us 7. When I add my like terms together, I am left with the original trinomial that we started with. So I know that this is my final answer. Know that it does not matter if you had put 7x and 3x in the opposite boxes. If you switched these two, you would have still gotten the exact same answer. You just would have factored things out differently. What I mean by that is if instead you had put 3x squared and 7, and let's say we switch 7x and 3x. So now they're in the opposite boxes. We would still be able to pull out a greatest common factor of 7, a greatest common factor of 3x, a greatest common factor of x, and 1. And it would have just switched our top numbers and our side numbers. But we would have gotten the exact same factors. In our next example, we're going to look at a trinomial where we can actually factor out a greatest common factor before we even start factoring itself. So what I mean by that is if we were to look at these three terms, well, I know I can't pull an x out because 6 doesn't have any x's, but 3, 9, and 6 all have 3 in common. So I know that I could divide an x out. So that's going to change all of these terms, and you can figure out what it'll change it to by dividing by 3 into each one. So 3x squared divided by 3, because we pulled that 3 out, is going to just be x squared. 9x divided by 3, because we pulled the 3 out, will be 3x. And 6 divided by 3 will be 2. Now that we've factored out the 3, we're left with a trinomial with a coefficient of 1. We know how to do these. We've done these before. These are so much easier. I'm going to go ahead and put this 3 in my final answer box so that I don't forget to bring it down, and I'm going to factor our trinomial. A times c, which is 1 times 2 is 2. Our b is just 3. 2 and 1 are the only factors of 2, and they also happen to add up to 3. If we wanted to use the box, we would use 2x and 1x. From this column, we could factor out an x. From this column, we could factor out a 2. From this column, row, we could factor out an x. And from this row, we can't factor anything out besides a 1. So our final answer would be 3 quantity x plus 2 times the quantity of x plus 1.